Very good evening, Vinay. How are you? Okay, so I guess we should start now. So yes, first of all, wishing you very good evening, everyone. It's going to be a second session on the mind chapter. So let's go. Let me just give you a quick recap of the previous class. So what we discuss or what we cover. Okay, so in the previous class, we are basically discussing about the preparation of amine part there. Okay, so in the preparation part, we already discussed about the preparation number one. Okay, that is the preparation number one from the nitro compound. There we discuss about catalytic reduction or metal acid reduction there. Okay, or electrolytic reduction. There we discuss about if you are using a strong acid or a weak acid, we are end up with a different type of product. And the second one is the ammonolysis, if you remember. So you will be having some kind of Rx there, and then we are using ammonia, so there is a formation of R NH2 there, and further you can go, and at that we are end up with the quaternary amine there. Okay, so like this. So this is the last topic, preparation part. So let's start with the today's class. So in today's class, of course, we are going to move further in the preparation part. That means we will continue about the preparation only. Okay, so let's go with the preparation. Let's see the topic number one of the class, that in today's class we are going to discuss about the preparation of the amine from the reduction of nitriles. Okay, so wait. That basically we are going to start further with the preparation part. So the preparation of amine. And in the preparation of amine, we are going to discuss about the third method. What is the third method? That from nitriles. Okay, some reaction you already know, some may be new for you. So let's see how. For example, if let's suppose I'm having RCN. So in the previous classes, we discuss about the reagent, right? If I'm using lithium aluminum hydride, okay. Very good evening, Anand. So it's not a very lengthy chapter, okay. So like after this, 2 to 3 more session for the mind chapter, okay. And biomolecule is also like hardly 4 sessions, okay. So not very big. Okay, so let's continue again. So this is a nitrile group. So if you remember the previous classes, that in this case, you can use three kind of reduction. That is the reduction number one, catalytic reduction. That I can use H2, nickel, the first case. Okay, so what we are getting? We are getting amines, simply. Okay, wait, that okay, let's just consider this later. And then that is a lithium aluminum hydride. So if you remember lithium aluminum hydride, convert the RCN into the RNH2. If you remember that in the same reaction, if I'm going to use the dibyl H, so what we are getting? Anyone? Can you just tell me with the dibyl H what is happening? It's a repeated part, right? Yes, please, anyone, if you know that if in the same reaction I am using dibyl H, so what is the final product? Okay, so aldehyde, right? Yes, very good, Arul. You are right. Aldehyde is the answer here. Okay, so we are going to get a aldehyde there. Okay, now one more thing I want to highlight here. Listen my point that although in this case this is H2 and nickel, okay, so this carbon is there. So please don't uh, understand like that way that I'm removing that carbon. No. Okay, so see, this is I'm having R and I want to highlight that, so that's why I'm using. Okay, so like carbon still there, and then this is a carbon, and then it is combined with NH2. Okay, so this is actually the meaning. Okay, so I'm using R, so it means R already contained that carbon. Okay, so actually this is how it's look like if you to consider the carbon, because carbon is not going to remove the carbon further. The only the nitrogen is combined with the two hydrogen there, so this is important. And the third one, that if in the same reaction I am using NaHZ, okay, so it's a salt amalgam, you know, right? So it's a alcohol. So amalgam, sodium Hz mixture and ethane, that is ethanol is there. Then again that is amine formation is there. Okay, so all three method is applicable. You can use any method there. Now let's discuss more about this reason because this is a new. Okay, yes, it's visible, right? So let's continue about this sodium part. So now one of the famous reaction again, that okay, if I'm using Na in the presence of some alcohol, any alcohol can be there. Okay, so if you're using sodium as a metal, sodium metal in alcohol. Okay, so now the question be like, this reagent is special for any kind of reaction. So now let's discuss about that reaction. So what is the name of the reaction there? That this is a naming reaction. If I'm using sodium metal in alcohol, and it's a special type of reaction or a naming reaction, you can say. So this is known as a, that is Bowlet Bowlet blank reduction. Okay, so what is the different part as compared to the previous one? In the previous one, we are just starting with the RCN there, but in this case, we have to start with the ester there. Okay, so this is a difference. So let me just write the general reaction. So how about the general reaction? Okay, so that is some R, CO, and O, CH3 is there. So it's a normal ester group. So we are just starting with the ester group, and then we are using sodium, and like sodium and this ethanol is famous for this. And then what we are end up there, it is a CH3 NOH. It means this part is going to convert into the ethanol there. First point. Okay, and plus that is R. So both are the alcohol there. This is also converting the alcohol. That is R, C, H2 and OH is there. So if symmetry is there, so two molecule. If not symmetry is not there, so we are getting different kind of alcohol. For example, what is the meaning of symmetry? Let's just consider an example here. Okay. So this is example. So let's see, this is a kind of example and mechanism. No, for this reaction mechanism is not so important, okay, because it's a free radical kind of mechanism. So it's not in a syllabus. Good thing. So it's a sodium C2 H5 NOH. So like in this case, if you're observing two carbon and a two carbon, so this time we are end up with the two molecule. So means that is a two molecule of CH3, CH2 and OH. If you have to observe the previous one, in this case that we are having different kind of group. So that's why different type of alcohol. So important is what at the end we are getting only alcohol is there. So this is the wait. Okay, I hope it's visible now. So this is our, that is the boulette blank reduction there. Okay, so this is all for the reduction. Okay, so let's continue further. That's it. Now let's see a kind of question for you. Okay, just answer the question. I want to convert the CHCl3, okay, into CH3CH2 and NH2. So you will tell me like which kind of reagent I can use. The question mark you would identify, okay? So like reagent, this question mark, let's say some P, okay? This is some P. So what is the P? Like P can be what? So first of all, that is you are using CH3NH2, okay? In the presence of a, okay, that's it, simple. Or the point number two that we can use, first of all KCN, and then lithium aluminum hydride in the presence of water. Or the point number three, that simply add ammonia hydrolysis. And option number four, none of these. Yes, please. Which one is the feasible part here? Casein or NaCN? Okay, Shiva, very good. Okay, you already answered the question, so very good. So, what, according to you, what is the correct option is here? That is this. Okay, so first of all, you have to use casein, or we can use NaCN as well. Okay, be noted, we can't use azCN because we already covered this part in the haloalkane and halurine chapter. Otherwise, that is the isocyanate is there. So then what is happening? This is a CH3 and this is a CN there. And then you can use any kind of reduction we just discussed right now, that is H2PD1 you can use, or that sodium amalgam 1 or lithium aluminum hydride. So according to the option, since we're using aluminium, lithium aluminum hydride and plus hydrolysis as well. So option 2 is the correct here. Okay, so this is how you can go with the reaction there. Yes, Arul, you're right. B and yes, Shiva, now you're right. Okay, so that's it. This is very simple question. Now let's see that I guess what is the number? Fourth, right? So right now we just discuss about four method totally: reduction of the nitro compound, second was the monolysis, and the nitrile fourth one. So let's see the fourth method, same preparation method, that is the reduction of amide. So you can say this reduction of amide is going to be the very much important part. Okay, so let's just talk about the reduction of amide. So in this case, that everyone you know what is amide. So you this is amide, this is simple amide. So if you remember, in the previous classes, we discussed about a point that if, let's suppose, you have to start with some NO2 group, and if you have to undergo, like, that is a partial hydrolysis, okay, partial hydrolysis. So we are end up with this amide, and if you have to undergo with fully hydrolysis, then at the end we are end with the COH group there, if you remember. Okay, so like it means that if I want to convert the amide into this RCOH group, okay, so I have to use a kind of reducing agent. Okay, so it's what? It's a kind of reduction is going on there. So let's see how. So any reducing agent you can use. So again, we are using a lithium aluminum hydride because it is a stronger one first of all. Okay, so step number one, and the second step is what? Nothing. It is simply representing the hydrolysis step there. So carbon will remain same. Okay, so it's a R, CH2 and NH2 there. So this is how simply we are end up with this. Be noted in this case, if you're to undergo with the hydrolysis step there, because this is very much important part of the conversion, then we are end up with the COH there. Okay, so on hydrolysis, this is the product, and on reduction part, we are getting amine there. So this is the simple part. Now let's solve a question, although let's leave that. Okay, easy question. So now answer this. This is important question. So question is this: ethyl isocyanide. This is the question for you. Ethyl isocyanide. I guess everyone you know what is isocyanide, right? So ethyl isocyanide on hydrolysis in acidic medium generate. So generate option number A, that is ethylamine, salt and methanoic acid. Okay. So it's not like I'm just explaining this thing just for like okay, just try to answer on the basis of this maybe. So it's a propanoic acid. It's ethyl isocyanide, okay? Propanoic acid and ammonium salt. Actually, this is a part of the carboxylic acid chapter. Okay, so let's check you're able to answer or not. And the ethanoic acid and ammonium salt. And option number D, that is the methylamine and ethanoic acid. Okay, So like in this case, this is I guess it's important understood that in this case carbon is three there because two carbon from the ethyl and one from the cyanide part. So like in this case, prop three carbon, ethyl and methane three carbon, ethane and ethanoic and ammonium salt, and in this case be like methyl and ethane. So like simply first of all count the number of carbon, that is a carbon is balanced or not, and then you can go further. So yes, answer this question. Wait, I have to set. Yeah, I hope it's visible now. Yes, please try to answer the question. Okay, there is a hint for you. Try to add the water molecule on an isocyanide bond. Okay, Shiva. Okay, so let's try to understand the question. Okay, so let's suppose if this is normally our cyanide part. So let's see actually what is happening. If let's say this is our C and triple bond, okay, and in this case same we undergo the hydrolysis. Like, okay, simple. So what is happening? That the carbon and nitrogen both are present there. Okay, so in this case, that OH may be added here and H positive simply added here. So what we are end up there, that is simply, this is like OH and a double bond, and this is a hydrogen. Further, that one more time water added, and this be like this way. Okay, but as you know, 2OH group or the germinal diol is never ever stable. So every time there is a water molecule form, and we are getting simply this is a amide there. So this is the point number one after the hydrolysis. Okay, and then if it undergo hydrolysis further, that is, let's suppose OH and H positive. So this is adding here, this is adding here. So what we are getting simply, that is RCOH and plus ammonia gas release. Okay, if you remember, as we just discussed, that on complete hydrolysis. Okay, this is how we are end up with the acid. But now, in this case, we are having isocyanide, right, in the given question. So let's see, that is the same kind of concept, that this is R and this time nitrogen is here. Okay, and then triple bond and then carbon. This is how the isocyanide look like. Okay, so this is isocyanide. Simply, okay, so let me just use the CH3 because we are discussing about the ethyl isocyanide, right? So let me just use one more CH2 and this is a CH3 there. Okay, so think about it again, that again if I'm adding water there, okay, so this time H positive simply and this is OH negative. Okay, so H positive attack here. I guess you already know that why I'm using H positive and carbon here, because just because nitrogen is more electronegative, nitrogen have a negative charge and a carbon has a positive charge, right? If you have to go with the previous one, same here. That is like same like this is how we are using there. Okay, so this is same like if you're observing partial positive and partial negative, and that's why H positive here and OH negative here, normal fanta, right? So let's just back again. So in this case, that H positive connected here and a OH here. So let's see actually what is happening. It is a CH3 and it is a CH2, and the nitrogen is connected with hydrogen, this bond break, double bond. Okay, and obviously there's a positive charge as well, and this is OH. One more time it's undergo hydrolysis. Okay, so let's see again that the same process is. Okay, let me just remove one bond and this is how it's look like. This is H positive and this is OH negative. Okay, so let's see again how it's look like. That is a CH3, this is a CH2, and this is NH2 and the positive charge here. And this is again that two double bond, 2OH bond is not very much stable, and of course that one hydrogen is also connected here. So it's look like that is a CO and OH. Okay, And further, if we undergo hydrolysis further, so what is happening again? This is H positive, okay, this is OH negative, simply attack in, this simply attack in, this bond break, right? So means what we are getting now, this is a CH3, this is a CH2, and this is NH3 positive. First of all, this is the case. And the second one, that this is HCOH is there. Okay, so this is the difference between this and the previous one. Even you can compare as well. Look at this. In this case, ammonia and acid, and in this case, that is one is acid, one is the ammonium salt. Okay, so why? It's obvious because the nitrogen part is here. So it means definitely that one is going to be the ammonium salt. Okay, and the second carbon is going to be the COH group. Okay, so it means what we are getting in this case, that this is a ethanoic, like ammonium salt of the ethane, and this is what? This is methanoic acid. Okay, so this is how it simply look like. That is ethanamyl salt. Let me just write the name as well. Okay, I am using, okay, let me just write because I want to give you the name. So it's a CH3, CH3, CH2, and NH3 positive. So what is the name for this? So the name is what? Ethyl amine salt, right? Why we are using salt? Because the positive charge on this ammonium salt basically. And plus one is this CHCOH is there. So what is it? It's a methanoic acid simply. Okay, so it's a methanoic acid. So let's see the correct answer for the question, that ethylamine salt and the methanoic acid. So according to the question, that option A is the correct answer here. Okay, so is this question now clear for everyone? Okay, Shiva. So you are right if it is cyanide. Okay, otherwise, if isocyanide, so answer is different. Option E is the correct. Okay, anyone, any kind of problem or issue, and if you want to note it the reaction, so this is how the reaction is there. Okay, then, so this is simple isocyanide. Okay, now let's see that the fourth preparation. So amide part is done. Okay, simple. Undergo the hydrolysis or reduction part here. If you have to go with the hydrolysis, we're getting acids. If you have to use the reducing agent, so we're getting that is the simple isocyanide. Sorry, that amines. Where is my video? This one. Okay. So I guess this point is now clear for you. Now let's move further. One of the famous reaction, that fifth preparation. Okay. So fifth preparation is known as a Gabriel Phthalimide. Okay, so as this is a naming type of reaction, so it's going to be the important one. So it's a Gabriel Phthalimide. I will tell you how that is it's become phthalimide synthesis. Okay, so this is the name of the reaction. Now, in this case, like which kind of substrate we are using, like for which kind of preparation we are using, this is used for preparation. It is very much important because when we are discussing about that how to differentiate a primary amine, or like which method only gives the primary amine, so there it is important. Okay, so it's a used for the preparation of primary amine. Okay, primary amine. Now in this case, which kind of reagent we are using? If we are talking about the reagent, so reagent, first of all, we are using alcoholic QH. Yes, naming reaction. So reagent ditto. Okay, we can't change. Be like okay, it's become NH. No, QH means QH, and then ROH, and then the third reagent we are using here, that is NaOH and aqueous. Okay, first of all, alcoholic QH, it means something is connected with elimination or like base. And the third, that is simply, it is a kind of substitution kind of reaction. So let's see that how they are different from one another, what is the point. And if we are talking about the substrate, so which kind of substrate? Since the name of the reaction is what? Gabriel Phthalimide. So means the substrate is going to be the phthalimide. So let's see what is phthalimide. So let's see actually how the complete story begin. Okay. So let's suppose this is a kind of benzene ring. Okay. So this is a benzene ring. And if this and this position we have to consider, so every time we are using thala, okay? Thala is there, like thalamide, thalic acid. So you can say that when two group are just ortho to one another. Okay, so this is a kind of thalic acid that this is, let's suppose, this is a COH is there, so it's become thalic acid, thalic acid. So similarly, that we're using thelamide, right? So see here, if you're noting something, the name is what? EMID. Okay, the name is what? EMID. So listen my point that for example, if this is NH2 group and this is connected with some CH3 group, so it's become that is amine, right? And the second point, that is, if let's suppose this is the CH3 group and it is connected with CH2 and NH2, so this is my amide group, AMID, amide. Okay, but if let's suppose this is a CH3 and this is some CO and this NH is connected with one more CH3, like that you can say if the amide N is further connected with some other R group, so it's become EMIDE. This is the difference here. Okay, so then the substrate is what? That is the thaliamide. Okay, so it means that first of all the position have to be thalic. Okay, it means let's try to draw the structure, just collecting our knowledge. Okay, so let's see that is how about the substrate. First of all, there is a kind of benzene there. Okay, benzene, cool. And then that imide we want, right? So let's see how it's different. That is a CO group and this is a CO group. And in between the CO group, this NH is sandwich. And this is this thalamide. Okay, so let me just write the name. So this is this. Uh, okay, wait, I am just wait, the spelling is wrong. Okay, now it's correct. Okay, so this is this telamide. So substrate is this, okay, reagent is this, and what is the product? That is a primary amine. Normal, Gabriel, that is the Gabriel Phthalimide. Now let's discuss about that how the general reaction look like, and then we are going to discuss about a kind of mechanism for this one. So let's talk about the reaction, that how the reaction, or you can say the general reaction. So this is a general reaction. We have to just start with this. Okay, actually it's look little bit scary, but it's easy. Let's see how. That is, this is a CO and this is NH. So like same three thing, alcoholic QH, and the second you can use any Rx. Yes, Rx can be changed here, okay? It can be changed. And the third one is what? NaOH, and this is aqueous. Okay, so see actually what is happening. So you know this is R, this is Rx is there. So what is happening? This NH part is combined with the R. Okay, it means amine formation is there. So what is the first thing what we are getting in this case? That is the first point is what? That RNH2. Okay, RNH2. And then second thing, since we are just consuming this, right? And one is this HX, okay, that acid. And since we are just consuming this, so this bond and this bond is open now. So just because we are using aqueous sandwich, so what is happening? Hydrolysis kind of thing. So we are end up with this. Okay, let me explain one more time actually what is happening. So this is phthalimide. Okay, we are using Rx. Rx combined with NH2. So amine formation. This is the thing which we really want here. That is a primary amine. Some HX there, and this is acid. Okay, so this is a common thing what can be changed here. That R can be changed. So this is going to be the deciding product in primary amine we are getting. So this is a normal. That is a Gabriel Phthalimide reaction there. Now, what about the mechanism? Mechanism is important? Yes, of course. This is really, really very much important naming reaction of this chapter. So let's talk about the mechanism part now. Okay, so mechanism. And one more thing, that is the salt we are getting basically. Okay, so it undergo hydrolysis further, but let me just write the salt, sodium salt. Na positive. Okay, I guess it's visible. Okay, then. So let's continue with the mechanism now. You can directly use a single stab or you can simply use the stab as well. So the step number one, if we are discussing about the steps, so step number one is what? That is the formation of thalamide. Okay, so first of all we are going to form the thalamide. So the step number one is what? Formation of thalamide. Let's see actually what is happening. It's potassium. Okay. Okay, so this is the first step number one. So just think about it. That is, this is a benzene and NH is simply sandwich here, and this is a double bond O, and this is a double bond O. Now, we are using alcoholic KOH, right? So what is the meaning of this alcoholic KOH? You know, alcoholic KOH is a very good base. Okay, so that's it. In this case, this OH negative ion is a base. It is going to abstract this hydrogen simply from there. Right? So what is happening? Water molecule remove. So water molecule remove, and now that this nitrogen have a negative charge simply. Okay. So what is happening? Nitrogen negative charge. In order to neutralize this, potassium have to be there as a counter ion there. So this is this, that is a potassium thalamide. Right? So the step number one is very simple, that we are going to generate the potassium thalamide. So it's a potassium thalamide. Okay, so this is a step number one. Now let's see the step number two. That is the nucleophilic attack on the nucleophilic attack of this potassium. Just think about it. That is, this is some negative charge. It means this is behaving like a nucleophile. So let's see the step number two. So let's talk about the step number two there. So how about the step number two in this case? That is the nucleophilic attack of potassium thalamide. That is, it is behaving like a nucleophile. That it's not like nucleophile is going to attack here. That is the nucleophilic attack of this potassium thalamide. Okay, so let's see how. You know, we're using Rx in the step number two. If you're observing, this is Rx. So it's simple nucleophilic substitution kind of reaction, and it's a single step reaction. It is a SN2 mechanism. Be noted. Okay, it's a SN2 mechanism. So it's a negatively charged and a double bond and a double bond here, and this is some Rx there. So we are going to follow the SN2 mechanism simply. So then what is happening? This R, this N negative attack here, and this is how X is going to leave. Okay, so let's see what is happening. This benzene and N is connected with now R. Okay, double bond and double bond. So this is a, you can say the next step, and in this case the KCl. Okay, because the potassium is there, right? So potassium combined with the 6 KX, KX release there. Now let's see the step number 3, that is hydrolysis step. So let me just write step number 3, hydrolysis. It means this is undergo the hydrolysis. Hydrolysis. Okay, let me just write the name for this. This is N alkyl. Why this is N-alkyl? Because see, this alkyl group is there. So it's an N-alkyl and then thalamide. N-alkyl thalamide. So hydrolysis for what? That is this N-alkyl thalamide. So hydrolysis of N-alkyl thalamide. Okay, so this step, let's see on the next slide. Now, hydrolysis step is going to be there. So, for the hydrolysis step, no need to use the arrow. Okay, simple hydrolysis. This is R double bond O, double bond O. And after the hydrolysis, just simply write hydrolysis, and then this is going to release. Okay, just try to understand actually what is happening. That uh, first of all, for the hydrolysis part, that is water molecule there, okay? So this is combined here. This is how the bond open up. This is how the bond there, and this is open here, okay? And means that basically it is going to break. So there's a formation of RNH2 and then water molecule. And in the last step, if you're observing, maybe you'll be like, "Ma'am, from where the water come? Aqueous NaOH we're using." So after once the salt form, the sodium is going to combine here. So this is how we're getting a salt. Okay, so this is the final product. Okay, this is a three-step reaction if you want to note it again. This is a normal general reaction. This is a step number one mechanism, formation of the potassium thalamide. Step number two, that is a nucleophilic attack of the potassium thalamide. And the step number three, that is a hydrolysis step. So now you're done. Any problem with this reaction? Okay, why I'm explaining in very much detail? Because it's important reaction. Okay, so now let's discuss some important point, okay? Or you can say the knot. Knot is very much important. So what is the knot here? Knot is the first point that only for primary amine. Only for primary amine preparation. Okay, now I can form aromatic amine. Anyone? From this method, I can form aromatic amine. Okay, let me just give you a kind of situation. Okay, so actually what is happening, this is how this is our nucleophile look like. Negative charge. Okay, and let's suppose this is a benzene. Yes, please. Is it visible? At least let me know now. Is this visible or not? No, right? We discussed so many times that if you are having a benzene and some halogen group is connected here due to the partial double bond character, due to the sp3 hybridized character, what is happening? Resonance, right? It's a partial double bond, difficult to break, and it is difficult to directly break the benzene and halogen bond. Okay, and the second point, that is in this case we are going to follow the SN2 mechanism, and hence just because of the SN2 mechanism this benzene ring hindered, right? First of all, this is already a very giant molecule, and phenyl, that is the phenyl ring is also there, for phenyl is also there. So just because of the benzene ring, so much hindrance have to be there. So what is happening? Due to the presence of phenyl ring, okay, phenyl ring, we can't form, okay, we can't form in this reaction, that is the primary aromatic amine. It means in this case we have to form only, that is the primary aliphatic amine. Aromatic amine, no, no, no is there. So it means you can say simply this method is only applicable for the formation of the aliphatic amine. Okay, so this is all for the Gabriel Phthalimide reaction. Now let's see the next preparation. Okay, so let me just check any kind of question. Okay, answer this question. Let's see you're getting my point or not. So this is a normal that is the thalamide, that is the same thing. Okay, if let's suppose this question come in an exam, definitely some of you are going to leave this question, right? Because that is first of all giant structure, phobia with the organic chemistry, so many problem. But think about it and then answer the question, okay, everyone? So this is a CH and this is a Br2 there. Okay, you have to identify the question mark means what is the product we are getting in this reaction. So there's some options for you. Option number one, this is this ring. Okay, this is N and this is a CH2 and the benzene and a Br. Double bond and a double bond. Option number A. Option number B. So it's a, oh wait. Okay, at least for this question, everyone try to answer the question because it's not difficult if you listen my point till now carefully. So it is a nitrogen and a double bond. Okay, nitrogen, oxygen, CH2, benzene and Br. Option number C, double bond, CH2Cl. And option number D, actually in this question, option is very good. CH2NCl. Yes, please answer the question. And it is a PYQ. Hmm. At least answer the question. Option A, option B, option C. What is the correct answer? Okay, wait, I have to change the position of my video right now. Yes, please. Just try to observe the question, and it is easy. Okay, Dashika. Dashika, you are here. I guess it's enough, right? So very good, Dashika. Option E is going to be the correct answer. Okay. So now the question like how it is correct here. Okay. So observe this. This is a negatively charged. Actually the OH is going to take this hydrogen simply. So OH negative is generated, right? So then what is happening? Think about it that this has a two choice. That is a choice number one. Let's say this is the pink one, and the choice number two. Look at this green one. So two choices there. So as we just discussed about the point that if the halogen is directly connected with the benzene ring due to the partial double bond character, it is very difficult to break this bond. Okay, it is not feasible. Okay, this bond can't be break here. So bromine is not going to participate. Then who is going to participate? This is going to participate. So it's not a feasible attack. If it is not a feasible attack, so if you're observing this option number C there, look at this, nitrogen is combined with the bromine side, so it's a wrong. Okay, and in this case like O negative, this is totally wrong, so only option A is the correct here. Okay, that why? Because in this case this is connected here. Okay, and now please let me know. Okay, so what do you think about this? Wait, after once that is this amine part did we are removing. Okay, so I am getting this kind of amine. So can you just tell me, is this amine is aromatic or what? Because we discussed, right, it is not possible to form aromatic amine from this. So is this aromatic or not? So answer is no. Okay, so what is the meaning of aromatic amine? Let's suppose that is this is benzene and that directly connected with NH2. So this is the meaning of that statement, that aromatic amine we can't get. Okay, so be noted that in this case, this portion is basically the aliphatic part and hence it is visible. Okay, so hence the correct answer for this question is the option number A. So this is the easy question, right? So any problem with the question? And very good, Dishika. Okay, so that's it. Now, now let's see, that is the next method. Okay, this is a kind of introduction. We are not going to start with this point in today's class. Okay, because it's a single class topic. Okay, so we are going to discuss about all the thing in the next class. I'm just giving you a kind of just introduction kind of thing only. So, in the preparation method, let's see the last preparation. Okay, so after I guess the number is like one, two, three, six method. Six method is there. So the sixth method is what? Rearrangement reaction. Okay, so as the name suggests, in this case we are end up with the rearrangement of something. Okay, so the first thing, and then it is further classified into the four part. Okay, you have to remember in a sequence, better for you, because all are almost similar and difficult to remember, and then we are going to face the difficulty in order to remember the reactions. Naming reaction, all four are very much important. So let's discuss about that. Is the first one is what? Hoffman. It's important. Hoffman, bromoamide degradation reaction. Okay, so as the name suggests, in this case, we are going to use that is something be like bromamide. It means in this case, we are going to use that a kind of this kind of thing. Okay, so we were going to discuss all these things one by one. So this is first of all, the name is what? That is a Hoffman bromide reaction. Now let's see the next one is what? That is a Schmidt rearrangement. Okay, next, that is the Lawson rearrangement. And then Curtius. Okay, now how to remember them? So like I used to remember be like that is high school living certificate. Okay, so you know HSLC. Okay, so H for Hoffman, Hoffman bromamide degradation, S for Schmidt reaction, and L for Lawson rearrangement, and C for Curtius. So this is how you to remember in a sequence. Better for you, easy for us to remember the name with reagent wise. Okay, so these are the thing we are going to discuss in the next class. Okay, so let me just quickly give you a kind of overview about the first one, that is a Hoffman bromide degradation. Okay, although again we are going to discuss all this thing. So let's start with the very first part of the kind of rearrangement, that is the Hoffman and bromoamide and degradation. Okay, so let's see that we are going to start with the amide. So first of all, the substrate is amide, Okay, and the reagent, if we are talking about the reagent is bromine and aqueous NaOH. Very much important. Even the side product is also important for the reaction. Like if you to compare the importance among all four reactions, so Wolfman bromide is the one of the famous one, important. Okay, and how about the product? In this case, the product again, that is the primary amine only. Okay, so since same like the Gabriel Phthalimide, in this case again, we are going to observe only the primary amine. Okay, so later we're going to discuss about that the test and all this thing as well. Okay, carbonyl test and all these things. So amine, reagent, product, primary amine. So let's see that how the general reaction look like. R CONH2. Okay, general reaction. So R this, and in this case we are using bromine. And yes, this question already asked one as a integer type question, that in a bromoamide reaction, what is the ratio of the halogen and a alcohol is there, or sorry, that is the base. So it is a 1 ratio 4, that is the 1 bromine and 4 NaOH consumed. Okay, so I'm repeating one more time, what is the ratio of the halogen versus the base in this reaction. So it's a 1 ratio 4. Or that sometime maybe you are end up with this. Okay, we discussed this thing already, that if bromine or like NaOH is there, so what is happening? This is a base, right? And this is a bromine. So actually what is happening, that one part is combined with the bromine, like this HBr, okay? And one is be like NaOBr is there. So if it is written, so this is also okay. This directly and indirectly mention us that is the bromine combined with the NaOH is there. Okay, so then RNH2, it's a primary amine. Okay, and plus the side product again is very much important here. That is Na2CO3 plus that is the 2NABr. Okay, this is the only naming reaction which we are going to remember. Side product plus stoichiometric coefficient as well. Okay, so if let's suppose I have to write be like this is my Br2 and plus this is 4NaOH. So stoichiometry have to be maintained here because ratio is really much important here. Like you can remember the side product directly and then you can balance the thing if you are smart enough. Otherwise, remember like 2, 2 and 1. And this is a simple general reaction here. Okay, so now, anyway, let me just write the knot as well. So what is the knot here for this? That 4 mole of NaOH are used per mole of Br2. So with 1 mole for 1 mole of the Br2, we are using that is a 4 mole of this. Okay. Now, in order to understand the mechanism, first of all, let's just talk about a kind of intermediate. Okay, because again and again we are going to get this thing. Okay, so what is it? Okay, this. Every time we are going to end up with this as a kind of intermediate in all four reaction. So this is an intermediate. Okay, so what is it? This is isocyanate. Okay, this is an intermediate. We are going to end up here. Okay, so what is this? That is a carbon combined with O, and that carbon form 4 bond and N and R is there. So isocyanate is a common intermediate for all four type of mechanism. Okay, so these are some important point about the this that is a Hofmann bromide degradation reaction there. Mechanism, everything or the other remaining three reaction we are going to discuss in the next class. Okay, because otherwise I have to start and then the next class is difficult to catch up all three reaction, right? So better to discuss in the next class. So that's it. This is all for the class. This is all from my side. Any doubt, any problem, now you can ask. Yes, please. Okay, that's it. Yes, please. Any doubt or any problem? Okay, I guess no. So, thank you so much then everyone for joining the class. Okay. So have a nice day. Thank you so much. Thank you everyone.